So here comes the solution, right? So before going to the solution, what you need to do first is to read the statement carefully so that you know how you can be able to apply whatsoever that you'll be having on the statement, right? So let's read the statement carefully and we can take out what we already know from the statement. So we are told that EB, this line and this line, they are tangents to the circle. So we know that whenever we are having a tangent like this, right? So this is a tangent. So we know that this angle here should be equivalent to this angle. This is what we can get from knowing that this is a what? This is a tangent. So this angle B1 is equal to this angle A. And again, we know that tangent from the same point, they are equal. So already we can see that this line will be equal to this line. So it will hence mean that this angle C3 will be equal to angle B1. Just before we can answer any question, already we can see that these three angles are equal, right? So this is what I can advise you to do before you can answer any Euclidean geometry question, right? So let's go to the second statement. We are also told that T is a point on AB such that TE is parallel to AC. So we can also see that TE is parallel to AC, right? So from using the parallel lines, we can also see that this angle A, this angle, it is equal to this angle on corresponding angle. So this is corresponding to this. So these are equal on corresponding angles, right? And also we can see that this angle here, T2, is equivalent to C1 on alternating angles. So these are alternative angles. Can you see that? So that's also that. So this is equal to this angle. And also we can see that this angle here on top will be equal to this whole angle like this. Can you see that? Yes. So already we have seen those situations before solving any question. So let's start solving now. So we can see that there's some of the things that are equal there. So now let's get to the questions. Let's answer the question. So on the first question, we are told to prove that B1 is equal to T3. So we are told to prove that this angle is equal to this angle. So already you can see, before you can go anywhere, you can see already that we have shown that already. So let's just now put that into words, right? So let's see. So it means that we need an angle that is equivalent to these angles, right? So by just looking, we can see that our angle B1 is equal to our angle A. Can you see that? Our angle B1 is equal to the angle A. And the reason being, this is the tan chord theorem, right? So this is the tan chord theorem, right? And then next we can see that our angle A, that angle A is also equivalent to angle T3. So this angle is also equivalent to T3. So angle A is equivalent to T3. And we said this is because of corresponding angles. Why are they corresponding angles? It is because AC is parallel to TE. Because TE is parallel to AC. Yes, you must also include that because those are the reasons why those are equal, right? So what can we do next now? What can we do next? So we can see that B1 is equal to angle A and also angle A is equal to angle T3. So if two things are equivalent to the same thing, hence those two things are equal. So we can say now, therefore, our angle B1 becomes equal to T3. And the reason being, it is because both are equal to angle A. And we have proved that. So now I'm told to prove that this shape TBEC is a cycle quad, right? So let's just show that with a maybe darker marker. So TBEC, so we want to prove that this shape is a cycle quad. So how can I prove that this shape is a cycle quad? So there are three ways to prove that something is a cycle quad. We can prove by the exterior angle being equals to the opposite interior, or opposite angles of that shape being supplementary, or angles in the same segment, right? But already I can see that I'm having something that is showing. Can you see? Already we've shown that these angles are equal. Can you see that? So let's just put that in words, then this shape becomes a cyclic quad, right? So let's see. So how can we start to prove that C3 is equals to T3? So we can say that our angle B1 is equals to our angle C3. And the reason being is angles opposite equal, sides are equal. So which equal sides are we talking about? We are talking about the equal sides BE and CE, right? BE and CE. But why are they equal? They're equal because tangents from same point are equal. So they're equal because these tangents, they're coming from the same point E outside the circle. So hence they are equal. So now we have proven that B1 is equal to C3. But already we know that our B1 is equal to T3, which we have proved again, right? So this is proven above. So we've proved that from the previous question. So the next thing now, we can just say, therefore, our C3 is equal to our T3, because these both are equals to B1. So we've seen two things, that these are equal. So when these are equal now, it will therefore mean that my TBEC is a cyclic quad. Why is it a cyclic quad? Because angles in same segment are equal. Because angles that are in the same segment, they're equal. Which angles are those? It is C3 and T3. So you can write that C3 equals to T3, just like that. Now let's move to the next one. Okay, so now we are trying to prove that ET bisects BTC. So ET bisects BTC. So we're trying to prove that this line here makes this angle and this angle equal, right? So from what we have already proven before, we proved that our angle B1 was equal to our angle T3, and this we proved that, so this was proven in 11.1. So this was already proven in 11.1, right? So now if we can check here, our angle B1 is also equivalent to T2. So this is also equivalent to this. Why? Because these are angles in same segment. How are they angles in the same segment? They're angles in the same segment because we proved that TBEC is cyclic quad. So whenever you prove something, you can continue and carry on using it as a reason. So this angle will be equal to this angle. So it means that therefore our angle T3 is equal to our angle T2, because both are equal to B1. Can you see that? So this is equal to B1 and also this is equal to B1. So which leaves this equals to this. So therefore it means that our ET bisects BTC because so now at this part of the question, it says that if you are given that TB is a tangent, so they said if it is given that TB is a tangent, so this is a tangent to the circle that is passing through B, F and E. B, F and E. So they said if that line is a tangent, so if this line is a tangent, we are required to prove that TB is equal to TC. So we are required to prove that this line is equal to this line. So the way that you can prove that these lines are equal is by proving that these angles are equal, right? But we are told that this is a tangent to the circle passing through this. So the only way that this can become a tangent is when this angle here is equal to this angle there, right? So this line is a tangent, so it means that this angle becomes equal to this angle there. Can you see that? So let's continue from that, right? So let's go. So it will mean that our angle B1 is equal to the angle E2, and the reason is because of tan chord theorem. Why are we using tan chord theorem? Because we are given that TB is a tangent. So if TB is a tangent, then it means that this angle become equal to that angle using tan chord theorem, right? But already we can see that our angle E2 is equal to our angle C2. So angle E2 is equal to our angle C2. Because these are angles in the same segment, we've proved already that TBEC is a cyclic quad. So these are angles in same segment. Why are they angles in the same segment? Because TBEC is a cyclic quad. So TBEC is a cyclic quad, right? So now our E2 is equal to C2 and our B1 is equal to E2. E2 therefore mean that our angle B1 is equal to our angle C2. So if our angle B1 is equal to our angle E2, these angles, and these angles, they are falling in which triangle? They are falling in this triangle. Can you see that? So if we can prove that these angles are equal, it means that these lines are equal. So we can now conclude by saying these are equal because both equal to E2. Therefore we can say our TB is equal to our TC. And the reason being is sides sides opposite equal, angles are equal. So these are sides that are opposite to equal angles, so it means that they are also equal, because B1 is equals to C2. Can you see that? Yes. So now we've proved that these lines are equal, just like that, right? Yes. So on this one, we are asked to prove that T is the center of the circle. So they said prove that T is the center of the circle. Okay, in this one, I can give you maybe two ways that I think they'll be suitable. But let's just see. So already we proved that our TB is equals to our TC, right? But if you can check also this angle here, it is equals to this angle, and this was already proven that is equals to this. So it will mean also our TC also is equals to our angle, our line AT. So also this line is equals to this line. Can you see that? So if this line is equals to this line and also equals to this line, it will mean that this line from here to here is equals to line from here to here. And this situation can only happen if this is the center of the circle, right? So you can say therefore T is center because AT is equals to TC, which is equals to TB. So the radius must be equal. Can you see that? Or we can use this long way. So this way that I'm about to give you now, it is a very long way. We can say that let our B1 equals to X. So our B1 equals to X. So if our B1 is equals to X, it means that also our C3 will be equals to X, because we proved that this is equals to this, right? And if our B2 is equals to Y, so now we let our B2 be equals to Y. So it will mean that our C2 will be also equals to Y, because we proved that these lines, they're equal, so it means that these angles are equal, right? But our TBEC is a cyclic quad, right? So our TBEC is a cyclic quad. So if this shape is a cyclic quad, we know that opposite angles, they're what? They're supplementary. So this plus this must give us 180, right? So it means that our B1 plus our B2 plus our C2 plus our C3 must give us 180. This plus this, because you know that opposite angles of a cyclic quad are supplementary, right? So now our B1 is X, our B2 is Y, and that one is also X plus Y give us 180. So now this means that our 2X plus our 2Y becomes 180. So if you divide by 2 throughout, it means that our X plus our Y becomes 90 degrees, right? So if this X plus Y becomes 90 degrees now, what does that tell me? Because this is a tangent. We know that a tangent is always perpendicular to the what? To the radius, or always perpendicular to the diameter, making this our what? Making this our center of the circle, or this line passing through the center of the circle, or howsoever that you can call that, right? So this is the completion of this question. See you on there. If you've enjoyed watching this, please can you please like this video, share this video, subscribe, and also follow us, guys. See you on the next one. Bye.